Some of the shepNotes slides provide a lot of information and insight into complicated and confusing issues. At the end of each slide, a chime and a small picture of my friend Becca are provided to indicate a good place to pause the video when you want more time to understand the material on the slide before moving on. Batch commands. A useful feature of the ti-nspire, the ti-84, the ti-89, and other TI calculators is the ability to place parameters and functions in lists so that several calculations can be performed with a single command. The series of individual functions, the sine of 30 degrees, the sine of 45 degrees, and the sine of 60 degrees can be placed in a list enclosed in curly braces and separated by commas, and the calculator will display the results in a convenient output list as shown in the following example. As shown, the sine of 30 degrees is 0.5, the sine of 45 degrees is 0.707, and the sine of 60 degrees is 0.866. On this slide, we show three different examples of how we can get the results of several related calculations in a simple output list by using a single batch command. Example 1 shows us how we can use a batch command to find 2 raised to 8 different powers. Example 2 shows us how to find the squares of 10 different values. Example 3 shows us how to get the results of 6 different numbers raised to their own values. Here we show 3 more examples of how we can get the results of several related calculations in a simple output list by using a single batch command. In example 1, we show how to display the square roots of 5 different values. In example 2, we show how to find the square root of 16, the cubed root of 125, and the fourth root of 16. In example 3, we show how to get the square root, the cube root, and the fourth root of 25. Now let's have some fun and see how batch commands can be used when the calculator is set to the graphics mode. The slope-intercept equation for our line is y equals mx plus b. M is the slope of the line and b is the value of the line where it crosses the y-axis. If b is set to 0 so that the line crosses the y-axis at y equals 0, the formula is reduced to y equals mx, where m is the slope of the line. In this example, as entered on the ti-nspire CAS calculator that is set to a graphics mode, m is replaced with a list of 5 different slopes, and the calculator displays 5 different lines, one for each of the slopes provided in the list representing m. For the graph, f1 of x equals x squared plus the list of intercepts 0, 1, 2, 3, and 4, the same curve is drawn with 5 different y-intercepts. From the lowest curve to the highest, these intercepts are 0, 1, 2, 3, and 4 as specified in the list of values added to the equation for the graphs. An object that crosses a vertical line more than once cannot be drawn with a single function. To get around this on a graphing calculator when drawing a circle, assign f1 of x to draw the upper half of the circle, as shown here, and f2 of x is equal to minus f1 of x to draw the lower half. On the ti-nspire CAS calculator, each half of the circle is automatically drawn in a different color. The circle can be drawn in a single color by combining the equations for the top and bottom of the circle in a list to form a batch command. The function y equals 3x plus 5 and its inverse, y equals the quantity x minus 5 divided by 3, are symmetrical about the line y equals x. If the output of a function with an input equal to x is supplied as the input to its inverse function, the inverse function returns the original value x. This batch command displays the function 3x plus 5, the axis of symmetry x, and the inverse function, the quantity of x minus 5 divided by 3. Hi friends, this concludes the second shepNotes presentation on batch commands. Watch for the next shepNotes edition, which will provide information and insight about acids and bases.